All right, good afternoon. My name is Will Kirby. I'm a sustainability leader at HDR. I'm also a member of the conference committee, and I want to thank all the other fellow members and Anita, who's walking around frantically making sure everything's getting off to a good start today, which I think it has been. So thank you to them, or to her, and to the committee as well. Today we're going to be talking about community impacts from wind energy end of service and component recycling. I'm going to kind of tee us up with some information specific to Nebraska, and then I'm going to hand it over to Frank Oteri. He is with NREL, National Renewable Energy Laboratory, out of Denver, Colorado. And Frank provides, he's a researcher, and he provides programmatic support for DOE's Wind Exchange Initiative. And he also continuously contributes to wind energy communication efforts on a variety of topics, one of them being end of life. Some of his past work has included researching and tracking annual wind-related manufacturing activities and also ordinances. So I'm sure Frank's already heard some good content, including at lunch, on the ordinance topic. So we'll probably touch on that a little bit during this presentation as well. And I'll let Frank give a little bit more of his background in the context of the discussion today. And also I want to emphasize that we would like a robust Q&A portion. So, and I'd also solicit input. If you have input on a certain topic, feel free as well to chime in, because Frank will get into it again, but part of what he's doing right now is stakeholder input. So consider yourselves stakeholders for this session. So please, stretch those vocal cords, be brave, ask a question, provide some input. All right, so as I said, I'm going to give a brief overview about Nebraska and decommissioning in Nebraska specific to wind, and also touch on blade recycling. So we've seen this map. It's in the back of your handout and probably printed elsewhere, but it's the map of operating wind facilities in Nebraska. So we're at just over 3.5 gigawatts of wind, which equates to about 4,500 turbines in the state of Nebraska. You can see heaviest concentration kind of in the northeast, north central part of the state. So I put together this bar chart using some of that same information about the possible. I say possible because I didn't consult the life or the status of blades at each of these projects, but just using a 20-year blade life, which is a reasonable estimate for blade life. Obviously, it can be shorter, can be longer. Using that information and the number of turbines per project, this is the projection of what Nebraska could see for possible blades to retire per year. So you can see we've got a few coming, a few hundred in the near term, and then once we hit 2029, 2030 and beyond, it's a steady stream of wind turbine blades. And that's not to say there might not be other projects that are already starting to consider repowering. With federal funding, there are going to be opportunities to repower that might financially make sense. And we were talking costs in the previous session a little bit. There's a great session earlier too from Advanced Forest Solutions and from Carbon Rivers, two different companies that recycle blades, which hopefully some of you are able to attend that. But we will start to see a steady stream of turbine blades in the near future in Nebraska. Also falls into that category. So if we're looking about even landfilling prospects, which Frank is probably going to get into in more detail, you take a look at the map of waste facilities in Nebraska. Again, as no surprise, most of the facilities are in the eastern half of the state, closer to our metropolitan areas. So there are no current recycling facilities within the state. I noted a few that I'm aware of, including the two gentlemen that spoke. Their facilities in Oklahoma and Tennessee, respectively. There are also facilities in Iowa and one in Missouri as well. Problem are, those are pretty far away to the hundreds of miles, and that is a big cost adder to the logistics component of getting a blade to the recycling facility. So that could be an issue. One other thing that I wanted to point out, and I was glad in Paul's presentation, in the state of Oklahoma, they have passed legislation mandating the posting of a bond for 125% of the recycling cost of the blades. And I think that's at the initiation of the project. I have to confirm that. In Nebraska, we've had proposed bills as part of LB 440, which I don't believe this was passed, but that would ban disposal of blades into landfills. So someone asked that question in the last presentation. Oh, we got a nice pop-up here on my screen. Hang on. Oh boy, let's get that out of there. LB 440 didn't pass, but it would ban the disposal of landfill blades in the state of Nebraska. So that question in the past presentation about are we going to see that more and more, and I think the answer was yes. We're probably going to see more of that come down the pipe, more of those sticks to incentivize or require recycling of blades. So when decommissioning in general, there are some, there are a lot of states rather that have wind decommissioning requirements as part of their state legislation. There are some, there's a lot of local as well, county by county. And in Nebraska, we have both. It is a mandate by state, and it is also a mandate in most counties, a lot of counties. If you saw Mr. Johan's or Senator Johan's presentation, said they work with a lot of different counties, and this is probably an area they work with them on. So I know some of you are not going to be able to read that in the far back, so I will try to help reread some of the important parts, but I pulled out a few highlights regarding wind decommissioning. So I'm not talking about recycling of blades strictly, just the decommissioning of wind farms at end of life. So again, in Nebraska, we have a requirement that you have to submit a decommissioning plan to the board operating private electric supplier, or obligating, the private electric supplier to bear all the costs of decommissioning. That supplier needs to post a security bond or other instrument no later than the 10th year of operation of that facility. And if this doesn't happen, the board may bring an action in the name of the state of Nebraska for failure to comply. And then at the end, it says does not apply if a local government entity with authority to create requirements for decommissioning has enacted similar decommissioning requirements. So basically saying if a local ordinance or there's a local ordinance in place, that takes authority over the states. So I pulled out a few of those county requirements, and one of these was in a county that got referenced in an earlier presentation too, Holt County, then Hamilton County. So the wind turbines shall be considered discontinued after 1 year without energy production. That was one that I saw in Senator Johan's highlights in his presentation. And this one was interesting, but this was talking about two things: the depth below ground that things need to be removed to, and also when it has to happen. So in this case, it was 4 feet below ground. Everything must be removed up or down to 4 feet. And then also it has to be within 180 days of the discontinuation of use. A lot of times you will also see a year. A year is a common decommissioning time frame to have that project decommissioned. And also the cost is a big component. The cost is important because that feeds into those security bonds. So the cost estimates in this case in Hamilton County shall be made by a competent party such as a professional engineer, a contractor capable of decommissioning, or a person with suitable expertise or experience with decommissioning. And the plan shall also identify those financial resources to pay for it. So also very common to identify who has to put together the decommissioning information. A few more things for Hamilton County that I thought were important to highlight. Waste disposal, talking about solid and hazardous waste and what or that you have to adhere to all local, state, and federal rules and regulation. No surprise. Interesting one too, kind of on the end of life for the entire project. Something to be cognizant of is what's happening at the end of the project. It's essentially construction again. So you are likely going to have cranes, other heavy equipment on site. So taking into account what the state of those roads are and what kind of impacts you might have on the project. So again, you're not coming in at the end of the project, getting rid of everything and leaving things in a bad state of repair. So also very important. And then switching over to Holt County, this is interesting because you probably get in the habit of thinking one ordinance is the same as all of them, because a lot of them do look very similar. But this one actually said had to go down to 5 feet or as negotiated between landowner and developer. And that said within 90 days, which that one kind of blew my mind. I don't know if that's changed since then. These slides are a couple of years old, but that was pretty quick to get that type of work done. So again, just a quick peek at Nebraska and an overview. If you have any questions for me, I'm more than happy to answer anything that I'm aware of from the state of Nebraska. And if you want to get into solar or anything else too, I would say that's fair game. And now I'm going to hand it over to Frank. And one more time, please be active with your questions, answers, inputs, what have you. Thank you.
Thank you so much, Will. My name is Frank Oteri. I've been with the National Renewable Energy Laboratory for 16 years now. Done a lot of work in stakeholder engagement and outreach. But primarily for the last 4 years, I've been really digging into this end of service topic. And when I talk about end of service, it's a lot more than decommissioning and recycling. It's repowering, it's the removal of components and the processing of those components during regular operations and maintenance. It's something that begins at the beginning of a project and ends like 30 years later at this point, 40 years later. So end of service is a really big topic. NREL at a glance, it's the nation's primary laboratory for renewable energy and energy efficiency research and development. This is wind energy, but it's also solar, geothermal, batteries, and just the spectrum of renewable energies. Stakeholder engagement and outreach, really, we are focused in on providing communities and decision makers with the resources and knowledge needed to make informed and educated decisions about energy. And it's fun. Like, I actually enjoy the work, figuring out these things and the differences between all these communities that we work in. No ordinance is the same, no community is the same. So even engagement is just something that varies by community. Getting into a little bit of what is end of service. End of service, again, it involves all the activities that lead to the removal or replacement of turbine components and or infrastructure. This is repowering, and repowering, as it says, it's the retrofitting or replacement of wind turbines either in part or full. When we're looking at in part removal, it's the blades, the nacelle, the tower stays in place, the foundation stays in place, and the infrastructure stays in place. So we're just replacing a few things for the components. When we're talking full, it's the removal of everything and then the rebuilding of another project. The land doesn't get restored and put in for other uses. It's continuing to be a wind project. So that's kind of where it differs from decommissioning. With decommissioning, we're talking about the full removal of a project. This project will not exist anymore in the way that it was. And then when these components are removed, all of them have to be dealt with in different ways. So they could be processed in terms of repurposing, recycling, or ultimately disposal and landfilling of the components. End of service matters a lot, and it matters for a few different reasons. Right now, the second generation of turbines are getting a lot older. When I talk about the second generation, it's the tubular steel towers instead of the lattice towers that were the first generation of projects. These are like 1.5 megawatt to 1.65 megawatt machines. And it's interesting watching them age, because it's not just this idea that they're 20 years old or something like that, but it's also the idea that they no longer qualify for the production tax credit. So the requalification of the production tax credit is a huge part of end of service. And it's a huge part of extending project lifetimes, but it's also a huge part of driving why blades are coming down and the number of blades that are coming down. End of service decisions, and I think I've already said that, and you're going to hear it 100 times from me today. End of service decisions are throughout the lifetime of a project. They're things we are deciding today for projects that are going to end 30 years or later from now for new ones. So an end of service decision, really, it starts today, but it's felt so many years later. So the rules that we're putting in place now won't have impact likely until further down the road. When we look at wind turbines and recyclability in general, 85 to 90% of a wind turbine is already recyclable. This is the tower and nacelle internals, but it's also the hub and the tower itself. These components are made from aluminum, steel, copper, and iron, all of which can be recycled pretty easily today. When we start looking at composite components, including blades, this changes a little bit. These components are a little bit harder to recycle today, but it is possible to recycle them today. We heard two people talk about them just before this presentation. When we look at this graph, it kind of shows, again, kind of this mapping of what blade waste can look like. or the number of blades that are going to be taken down in a year. But I think the important thing to note is that this was figured out before the production tax credit got extended. And so the driver of the production tax credit could actually make it so that it's going to be more blades than we anticipated 3 years ago when we did this report. So we could be seeing something that looks similar to this, but it could also have a different number of blades that are actually being retired. When we're looking at the work that I'm doing now and kind of diving into this idea of what are the community impacts from wind energy recycling and end of service, again, it's this older fleet and that's really started this, but it's also the increased deployment that's coming. So more turbines are going to get installed, which means more components are going to have to be processed at the end of their life. And this has created a real need for end of service information and an opportunity for my current effort. We started about 12 months ago with this phase of this project, and it really started with conducting interviews with different stakeholders. We conducted about 30 interviews with stakeholders that varied from recyclers to turbine manufacturers to land restoration experts. And this was to get a feel of what's going on in terms of the actual activities that happen in communities and the processes to take these components down and to recycle them and to process them in general. We expanded that when we got to our interview stage, and we included the original stakeholders, but we also started to include state agencies, community organizations, and local decision makers to get their input in terms of how these activities impact their communities. And we've finished that, that roundtable phase. We got really super specific in terms of the topics that we talked about, conducted 10 different roundtable discussions, and really allowed the stakeholders to just brainstorm and talk about anything that fell within these topics and even beyond that. And really to get this feel of how one activity happens, but then it's felt by multiple parts of the groups that are working in this, but then also multiple community aspects in terms of the people that are living with these activities that happen. This goes again, end of service. It happens early and it has long-term impacts. So these are the end of service begins today for something that happens 30 years down the road. End of service decisions are found in local ordinances and in land lease and in decommissioning plans. And really these things define the approach to decommissioning because decommissioning can be done a number of different ways. It also defines how a project or how much of a project will be recycled. And then it starts to really give a picture of what the cost of decommissioning is going to be, because whatever your activity is and what you decide in terms of an approach has a specific cost to it. And then in terms when we get this plan and we get this cost of decommissioning, that ultimately influences the decommissioning bond that you're going to be setting up. So if you don't know the approach that's going to be taken, you don't know the cost of that approach, you don't know the impact of that approach, and you won't be able to get a decommissioning bond that reflects what your community actually wants. So having knowledge of all of these things and defining them early in the process really puts the community in an advantageous place where they can have rules set and money to take care of decommissioning and end of service in the way that they want. Here's a few examples for this. When we look at felling versus disassembly of turbines, this is typically defined in a decommissioning plan, but there are huge cost differences. When we're bringing out a crane to disassemble a turbine, that is expensive in some communities, not readily available, and so it's time and money to bring those in. When you fell a turbine, which is a controlled knockdown of a turbine, it's either by cut or blasting. And that is a lot cheaper of a process, but it has different impacts associated with it. So you're disassembling a tower using the crane, you're knocking over the tower and you're cleaning up the mess, essentially, if you knock over the turbine. That mess is typically fiberglass. And the tower will come down and the blades will splinter and fracture, and then you have to clean up the fiberglass around it. But it's also the metal. When you're doing your metal cut, they'll bring in big magnets and get up all the metal shavings around the site. But there's, again, huge cost differences. It's expensive to bring in a crane, and it's not expensive to just knock over a turbine. When we look at recycling versus landfilling, this is a similar thing. It's defined in a decommissioning plan, typically. They use a proximity to really be able to say, we will look at recycling if a solution is within a certain distance, because the transportation aspect is so expensive. So if they have a solution within 60 miles, it might be a viable option to choose recycling, but they won't even look at it if it's not available within that 60-mile radius. Huge cost differences again with recycling and landfilling. Landfilling is by far the cheapest option in how to process blades. Mechanical processing is the second lowest cost, and that's the using the blade material for concrete application and a replacement fuel in that. And then we have pyrolysis and sovolysis, which is the more conventional recycling, which is definitely a higher cost than the other two options. When we start defining this in the decommissioning plan, and when we look at can recycling even be done? Can blades be recycled? This is the first step in will our project be fully recycled? If we're not considering this within a decommissioning plan, the default is landfilling. That's not saying that all developers will end up doing landfilling. That's just saying that the cheapest option available is landfilling. So if the developer does not have a preference in it and does not have a desire to do it, most likely it'll end up being landfilled, which is interesting. And again, it's just an impact to total recycling. So you won't be able to recycle your whole turbine at that point. You'll be able to recycle the 86% that we showed before. Full removal or partial removal of below ground infrastructure. This, I think, in my mind, also kind of has this idea of impacting total recycling. A lot of the time we talk about turbines as themselves instead of a project and the associated infrastructure. When we leave the infrastructure like foundations and below ground cables in the ground, those components aren't being processed. They're not being recycled. They're essentially being landfilled in place, which is fine. They're inert objects, and there's no real impact to it other than when we consider future land use. And that becomes more of an issue further down the road. If someone's going to look at a different use for their land after a project is decommissioned, then all of a sudden we are talking about who's going to pay for the full removal of this. So if it's not done during this initial decommissioning, someone else is going to be in charge of footing the bill at that point. And for full removal and partial removal, it's kind of defined in two places. You look at the local ordinances and state ordinances that really can start dictating that, but also in land leases. And I think that's the real interesting thing. Even though a community might have an ordinance in place where 3 to 5 feet of the foundation needs to be removed, there is a opportunity for the landowner to say that doesn't work for me. And if you want to site this on my land, you're going to have to remove the full foundation and all of the other equipment. The developer has an opportunity to say no and to say that this doesn't work for us. We're just going to go find someone else to put a turbine on their land who doesn't have as strict rules and regulations. But that doesn't mean that you can't ask for it as a landowner. When we look at blades and the processing of blades, and this includes the segmenting or the grinding of blades, both of these activities have community impacts. And really it's the particulates and the fiberglass shreds that are produced. They have to be cleaned up and removed for the site to be able to continue operating in the way that it used to. When we look at the equipment used to process these things, some of it's modified to kind of reduce the impacts. It'll have water jets or self-enclosed systems for the grinding to be able to really capture these particulates. But at the same time, it's just to reduce. It's not to remove or to mitigate fully. So there's still going to be cleanup requirements that have to happen. And those cleanup requirements, there currently isn't a best standard or best practice for the industry. And this isn't something that is typically thought of when we consider ordinances or even decommissioning plans. So for communities to be informed of this, I think that there's still a lot of work in getting some information out there. Landfilling is super, super interesting because landfills deal with waste, and they're really good at it. Some of them are excellent at it and don't consider blade waste a problem. It gets a little bit different when we're talking about community landfills as opposed to private landfills, though. And it depends on where we're talking about in the country. In the Northeast, there are different land constraints than places like this, where there might be plenty of landfill space for the processing of these blades. But when we talk about space, we're talking about it in multiple ways. It's not just the volume of space available to put the blade, but you also have to have the space to process the blades. And you have to have the space to still accept all the other waste that's coming in without slowing that down. So space has to be thought of in multiple ways when we look at this. Landfills also have to consider, do they have the right equipment to downsize these materials and to reduce volume? Blades are made to last a long time. They're made to be durable, and the segmenting and processing of them is difficult. And if you don't have the right equipment, you will chew through it. And even more importantly, you might hurt someone. And I think that the personnel is the last portion of this. You have to have the people to process, but then you also have to have the people to landfill it. And then landfilling requires covering. So every single blade that you're putting in the ground at the end of the day, you have to cover at the end of the day. So it's not as simple as here's our pit and we're going to be putting blades there tomorrow too. It's here's our pit, I have to cover it at the end of the day, and we're going to be putting blades here tomorrow too. So there's a whole process that is really unique to this. Repowers are a little bit different. They fall under end of service, but they're not really dealt with in decommissioning plans. They're not really dealt with in ordinances. And I think that with land leases, there's room for them to be thought of within there. But specifics, it depends on the project, really. But what repowering really does is it offers an opportunity for a new permit to be put out, and for the landowners to really have another chance to say, hey, we want to be a part of this project, and these are the things that need to happen for us to be a part of it. So this allows the community and the landowner to really update the conditions of the project. And it could be an update of decommissioning plans and the frequency of those updates. When we look at inflation recently, it's really changed the equation of how people have looked at these updates, because the cost of decommissioning has changed drastically in a very short amount of time. So the ability to say, now we need this looked at on an annual basis, is super important. It can also be an opportunity to say, we do not want these blades landfilled. It's in our community's interest to not have them landfilled here, and we would prefer to have them recycled as well. And if the community has enough, words not registering, sorry, has enough pull, they'll be able to get that actually passed. Then I think that the other aspect of this is it's an opportunity for some landowners to say that we no longer want to be a part of this project. That's not a guarantee that their turbine will be removed. It's possible that the turbine will stay as is and it just won't be upgraded, so that they'll have to finish out the end of their contract. But there's a chance that and developers have removed certain turbines from projects. And I think the main thing that communities and landowners are really interested in is this idea of it's an opportunity to renegotiate what you're getting paid. For repowered turbines, and if it's a new turbine, these are not, you're going from 1.5 to 4.5, 5 megawatt machines. If you're going from a partially repowered turbine, it's a little bit different in terms of the incremental change. You're talking 1.65 to 1.83 megawatt machines, which isn't huge. But at the same time, both of those kind of equate, we're creating more energy, we should be getting paid more scenario. recycling and repurposing, all of these different options have different costs and have different localized impacts. Cement kilns, you're replacing coal. That's what's used in the cement kiln process currently. And you're using ground up blade material in that replacement. This change also has a change in those emissions that are released. So what's the difference between the off-gassing of cement kiln with coal versus the off-gassing of cement kiln with wind turbine blades? That's something that we still need to learn more about. Pyrolysis, the previous session, it seems like it's contained and reused oils and chemicals to be able to get these off. But what happens, worst case scenario, if there's a spill, if there's some kind of something goes wrong where those chemicals are released? I think that's still a potential impact that should be more understood, and that communities have to understand before saying we want this in our community. Pyrolysis, there are potentially energy impacts. You're heating up the blade, and that takes energy. So where is this energy coming from? And then repurposing. When we're looking at repurposing, is it just a delay if we're creating something new and then we're not recycling it at the end? So we're just delaying the inevitable landfilling of this, or is it something more and just a stopgap till we get to inevitable solutions? So I think there's a little bit more to learn about that. We have an end of service guide that we've been working on. This, in its current iteration, really defines the foundational aspects of wind energy end of service. We're working on updating it currently and getting into kind of these community impacts and what communities can do to address these impacts. So that edition will hopefully be done in the next couple months. Fingers crossed. And we're going to continue to build on this document. I think that in many ways it's just a start, and this is definitely not the finish line of where we're heading to with things. So what we learn in the next few years is still going to have to be incorporated, and especially as offshore wind gets more defined for what the decommissioning process will be for those components, and what the needs are going to be in terms of like a port space and all sorts of wonderful things. So a lot to learn still, and a lot to be incorporated into this guide. And I think that's the end. Thank you.
All right. Thank you, Frank. And if you want to sit, you can too. Up to you.
Oh, awesome.
Up to you. I'll give you this mic, but I'll get things kicked off here with a quick question, and then hopefully get some courage from the audience. The landfilling topic, have you, with your stakeholder events or conversations, have you had any feedback from the landfill operators themselves regarding salvage of blades for potential recycling?
One of the topics that we talked about when we were talking to the landfilling people, it's interesting. When you look at blades that have already been landfilled, in the landfill's mind, it's already been processed. It's already been paid for. It's commingled with other waste likely. So now all of a sudden you have a community that you're going to say, we want to remove these so that we get space. It's going to cost money. We're kind of interested in you paying for that because we don't want to pay for it. If it's county landfill, most likely it's coming from county funds anyway. And you're going to have to deal with the smell as we uncover and remove these things. And that's really there's some question marks in terms of whether communities will be accepting of that or if they would rather have it in the ground, I guess is the best way to say it.
Okay. Any other questions out there?
Thank you. The ability to bring on-site kind of machinery to chew up the blades kind of in a contained fashion, reduce it. Is that technology out there? You mentioned it briefly, I think, but how viable is that? Like if I'm more than 60 miles away from a landfill, is there money to be made chewing this stuff up into bales, right?
It exists. And there are people that do it. It's interesting. I think that when we look at that kind of process, we're getting almost ahead of the communities in many ways, because the ability to permit these things and what the best practices to remediate the site afterwards still have to be figured out. And for me, at least, it's a little bit concerning. Like the idea of someone coming into the community, processing these blades on site. And if that restoration doesn't happen quite correctly, the land getting put back into use, there are challenges with it. And I think that when we look at it from that kind of perspective, it doesn't serve itself well until we get those best practices in place. And then I think the other perspective is where's the material going? And if the material is going straight to the concrete plant, for example, we're skipping a step of quality control, is what was brought up to me. So the idea that this material that has to be a specific way, like if you don't use it and if it's not in the proper condition, it can damage the equipment that they have. We lose control of being able to keep that quality control level. So I think that there are a couple issues with processing and grinding blades on site at this time. Can all that change? Yeah, absolutely. It's just going to take a little bit of time to mature.
And I do have one I actually meant to ask in the last session too, but with all the federal funding through IRA and IIJA, we've seen some efforts or some money allotted for different manufacturing. Has there been any monies allotted for recycling programs that you're aware of?
I believe so. I believe that there is a recycling challenge through the bipartisan infrastructure law that is supposed to come up with unique, innovative ways to create recycling processes, if I'm not mistaken. So yeah, we've started with that, and even this project that I'm working on now is funded through the bipartisan infrastructure law. So recycling is really, I think, on people's radar in terms of being a topic of interest. Hopefully more and more funds will be able to really help solve these issues.
Thank you, Frank, and thank you everyone for attending.